Okay, I think that we are ready to start. So, again, thank you for joining me today. We are going to talk about navigating net zero and some effective strategies for energy efficiency with cove.tool. So, just to introduce myself, my name is Marie Claire Monasterio. I have a background in architecture, and then I study a master in sustainable design. So, I have like very diverse and different experience in the AEC industry, first as project designer and project leader, and then more as a sustainability consultant. And now I'm part of the research team here in cove2. For the agenda today, I divided it in four main topics. First, we are going to understand a little bit what is actually net zero energy, then how we can get started with it. And for the third, we're going to go deeper on that workflow and tips to run simulations. And at the end, I'm going to show you a case that we use here in cove2 that we just finalized for one of our clients. So as you all know, the building sector produces around like 40% of the world carbon emissions. So the net zero energy initiative will be crucial and very important in trying to curb that global warming in the decades to come. To meet the goals of the Paris Agreement, the building sector must attain net zero carbon by 2050. And what does mean is that most of like countries around the world are trying to make carbon pledges to be able to like US to be able to meet these goals by this year. However, we can see at the bottom left here some countries like Suriname and Guyana that they have already achieved carbon neutrality, or in the other opposite, like Australia and Singapore, there are countries that they know they have the intention, however, they haven't set anything at in goal, like in set in stone. So for today, I want to just remind a phrase that I really like. The greenest building is the one that is already built. And I think that it emphasizes the importance of adaptive reuse and retrofitting our existing buildings to meet like our ambitious goal like net zero. So to start with our biggest topic today, I think that we need to understand first what it is. And I bring in four main topics, like four main definitions by the National Renewable Energy Laboratory, that is the prime authority in this topic, and how they define it. So first, we need to understand what is net zero site energy. What it means is just a building that produces as much energy as it consumes on annual basis. Then we have the source energy because over 60% is lost in generation and delivery. For to be able to be net zero source energy, we need to produce 100% of the energy use to generate and deliver from the power plant to the site, plus that site energy that I just defined, right? Then for the third one, we have the net zero energy cost. This will be a building that produces more, so it will sell more power than the utility that it purchases. And then we have the net zero emissions. This building will produce as much renewable energy as it uses. It could be by offsetting any gas emissions that it creates. So it could be produced on site by renewables, or it could also be purchased by RECs or carbon offsets. So after understanding like all these concepts, why is really important? Like net zero initiative is not only a technical goal. This is a very comprehensive, holistic approach that addresses like multiple dimensions in the sustainability and climate change. So for environmental, we are reducing greenhouse gas emissions. We are protecting our ecosystems. For economic, we are reducing costs in our properties, so the property value is increasing at the same time. In health and well-being, we are improving indoor air quality and occupant comfort. In resilience, we are reducing dependence on external energy, but we are also setting a positive example of innovation and leadership. So very highlight, I want to bring this up because there's some conflicted terms in the industry. So if you see, let's zero net energy building or net zero or energy neutral. Don't worry, they all mean the same. So don't get confused by it. So now that we understand what it means, net zero, how we can start? That's the big question all the time. So I define it by four big strategies, right? We need first to eliminate all unnecessary energy consumption from our building operations. Then we need to reduce through efficiency all necessary building operations. And then three, substitute conventional energy sources by installing renewables. For the last step is that we need to compensate through offset any remaining energy that we couldn't eliminate, reduce, or substitute. How this translate to design process and like architectures or AC industry in general. So for new or existing buildings, I think this framework will work for you. We have also main four things that it relates to the concept that I just defined. So for location, in order to a building, try to pursue to be truly net zero, the location is really important because we need to place our buildings in an area with good access to sunlight, the ability to store water that we can reuse in the building operations, and the and wind panels that we can utilize maybe for natural ventilation or cooling. Also, the location will have a weather file um, that will allow us to understand what is our climate zone defined by ASHRAE and what it could be the best strategies to start our projects according to that climate zone. Different climates will require heating and cooling strategies completely different. For example, a building in a hot climate needs effective cooling system, while one in a cold climate will require more efficient heating solutions. So I know that sometimes as architects, clients come to us like with a specific lot where they want to build. So probably location will be from the four variables that I'm going to present, the most difficult to control. The second one will be orientation. It will help us to eliminate and reduce. And I think that we are all very familiar with these terms, but it's very important to maximize natural light for reducing the need for artificial lighting. Also, understanding if we have like access to natural shading, like how we're gonna design all those fenestrations, size, what is the best facades where we can have a higher window to wall ratio or where we need to have less percentage. Also, to try to control the solar gain, we need to take advantage of our sun path. So, understanding where we can optimize solar gain in winter, what areas we can optimize maybe um, cooling loads for the summer. So in some cases, also the orientation will facilitate strategies like natural cross ventilation that will not only improve your indoor air quality, but also will reduce the reliance on the mechanical systems. That is, for in some cases, is key in the design process. Also, just by proper orientation, we can even reduce the HVAC loads of the building and increase the energy efficiency just by 20 to 50%, and also reduce operational costs at the same time. The orientation will also will dictate where your solar panels will be placed. So it's very important to be mindful and try to run analysis rate radiations on hours, um, running massing studies along with this for understanding how you can approach your projects better. Going deeper into design, I think the most important thing that you need to check at the beginning is the energy code. Some areas have more stringent energy efficiency standards, and other ones doesn't have some higher standards, but they offer some incentive for green buildings. So that will influence your decision if you wanna follow or pursue one strategy instead of another one. For the envelope design, we need to make sure to define like high quality insulations in our assemblies to prevent problems like heat transfer or heat losses and improve as much as we can our thermal performance. Things like air sealing, air tightness is super important, like waterproofing too, because we prevent unwanted air infiltration or water infiltration. For the HVAC system, I will say that especially if it's existing building, like it's really important to understand what type of system can you improve and like how you can upgrade it even with the smallest things. For example, like if you just implementing like energy recovery ventilation, that is ERVs, or HRV, that is heat recovery ventilators, that will allow you to like just improve the recover energy from that exhaust air, and we are just improving our energy efficiency just by that. Also, like installing building energy management systems, even if simple or advanced, it will help you to monitor and control energy. Also, strategies that we all know, like energy efficient lighting, like LED or lighting controls for daylight or occupant sensors, is really important. Now, getting to the last one, that is renewables, is when we substitute and compensate. For this, we have two. So for the substitute will be all these renewables energy, and for the compensate, like I mentioned before, just be mindful of carbon offsets and RECs if it's in the table. This is something that you always have to talk with your clients to see what is on the table and what is not. Now, how we can run all these simulations after understanding the definitions and important strategies. So the first one that I define for you is conducting a benchmarking report. This will be important. You only need project address and building use type, so it's very easy to run. And my only tip that I'm gonna say is like if you're running um, VTRAS or our baseline page, just check the energy code that is being automatically populated in that input in the tool, just for accuracy. Sometimes local authorities or some states are like constantly upgrading like the energy codes that they need for compliance, and even when cove.tool is constantly updating their information and database, this is something that it could be in that process while we are working towards upgrading our things. The tools that you can use, like I mentioned, Vitras and cove.tool. For the second step is running a baseline scenario. Your baseline scenario in a net zero roadmap will be different from your benchmarking. Why? Because your benchmarking is just running by minimum code requirements that the tool is populating for you. But for the baseline scenario, we need to take into account all those existing conditions, our values, HVAC systems, building performance data if you have available. So my tips after just being sure of your energy code, just double check any input for accuracy, involve the stakeholders, like any client that you are in contact that is asking you for the net zero energy simulation, and check that the geometry is properly dividing in the building use types, because the building use type will define also like your schedules, and that will have an impact in your energy consumption. For this, you will utilize baseline page. The the following steps that I'm going to mention, the third and the fourth, you will only be able to use baseline page too. For the third step, now when you want to try to create those scenarios, you only need the baseline that you just created and the inputs that you would like to test for two or three scenarios. So I added like a photo here just to give you an idea. I recommend to create a data table where you clearly define what will be the options for any scenario that you want. You can run as much scenarios, as many scenarios as you like, but as we already just went through the process, we recommend just to have baseline 50% of reduction, like as a better option, and then net zero, that is your best case scenario. When you are running the simulations in cove.tool, we recommend that one simulation is tied to one cove.tool project. That's why, because when you start changing and modifying like all the inputs in the tool, that will like, and you recalculate for those that have used the tool, you are gonna have, you're gonna update your whole cove.tool project. So you're gonna lose all the data that you use for the first simulation. That's what I think the data table will help you a lot, because then you will have in just one place all the assumptions. You're going to ensure that some consistent patterns like occupancy patterns, climate data will be all the same across all the scenarios. Like I mentioned before, if possible, involve your key stakeholders that really make an impact. Just by the case study that we did, um, it was it was very important when we talked to them, and we needed to have like several conversations, because we needed to understand what was in the table, especially with a retrofit project. If it's not new, what is in the table, what is negotiable, and what is non-negotiable for them from the beginning. Also, if you are trying to define these scenarios and you don't even know where to start, we always recommend the cost effective measures, cost benefit ratio, because you need to like try to make actionable items for them, for people understanding how are they can do like incremental improvements that are easy to do. So maybe renewables will never gonna be the first step to try, because that's the ones that it will be a higher investment at the beginning. The last step will be just to organize your results. This could be however you want. Basically, I brought you some examples, like what we do here in cove.tool. We present some like comparative tables, also diagrams with a comparison breakdown by systems. So basically, what you are gonna need for this is only your data extractions for each cove.tool project. You can also try to play with something like this. This is something that Burlington Electric Department did for one of their roadmaps for energy, and it's just like an energy pyramid that is telling you how to reduce and like the priorities strategies that you must take. So basically, you can play around with however you want for that roadmap for your clients. Now, to finish, I want to introduce you to the case study. This is a confidential commercial building. It was a retrofit. The client moved to this location in 1976. So basically, the building was there before the energy codes were even a thing. So that was the biggest challenge. It's located in Ohio. The energy code at the moment that we started the project was IECC 2015. Climate zone is 5A, and the building area of the project is 93, 93,550 square footage. Like I mentioned, it's an office, and the window to wall ratio is 11.10, so very low. So the first thing that we did, as I recommended to you for your projects, is the baseline. And like I said, this was very challenging because we needed to understand the existing conditions. We didn't have any drawing plans. So we needed to assess on site basically a lot of things to understand. Okay, so we don't have daylighting or occupant sensors at all. We didn't have any heat recovery system. The thermal envelope capacity was very low. There was no building energy management system in place, not even LED. It was very low, the percentage of LED that they have in their buildings. I think, if I remember correctly, it was around like 20%. Uh, but they just went through um, an latest upgrade in the HVAC systems, because they knew that they needed to try to just make something about it. So they decided to upgraded to VAV system with reheat, gas boiler, and DX. Like these upgrades actually help us a lot because at least the HVAC system took them to meet code only by the mechanical system. So to compare the scenarios when we start playing around, this is a very high level overview of what we did. We start playing here, for example, like, okay, let's create a scenario where they are just meeting energy code at this point. Then we need to go for a 50% of reduction just for them to have like another incremental improvement that is very easy to achieve. And then at the last thing, we are going to do the ones that are very like a higher investment for them because they need to change HVAC systems, install renewables, or like really invest more in the building energy management systems. So I will just mention that the first one for them, like just to meet code, it was the one that has like the highest impact on like the changes. However, that after like going through that and review it with the client, they were very happy because from IECC 2021, that is actually very a stringent code to 50%, it was an easy piece to retrofit. Something that I forgot to mention is that I mentioned before that we started the project with IECC 2015. However, when we were on the process to work on this case scenario, um, Ohio adopted the new energy code as the 2021. So that's when we added one of the scenarios just to understand how was that upgrade to 2021. For the last thing, we just went through our roadmap. Our way to like produce that roadmap for the clients was something like the image that you are seeing. We decided that we wanted to isolate each system to understand individual impacts. So we divided by lighting systems, building energy management systems, HVAC, building envelope, and PVs. And of course, we found out that the overall impact, the best one that has was HVAC. So it was the biggest impact that we found. I think that something like very good to see here, if you see the color, so the lighter blue is the net zero option. And you can see that obviously we are reducing from 81.97 to 34. That's great. But even if they don't go for the net zero option, that it was like changing HVAC systems, installing renewables, they could still get a pretty good energy, like reduction in energy consumption by just doing like improving the building envelope, getting those R values to a minimum code, getting like a building energy management simple, not even the most advanced technology, just installing 50% of LEDs with 50% of the lighting sensors and occupant sensors. So there's options that you can do to get a pretty good reduction in your energy usage without even just saying that is, oh, we just only need to use renewables, because if not, is there's just no way. I will say that a net zero energy building will always have some type of renewables installation and some type of offsets if needed. With this project specifically, we didn't need it to go to offsets at all. We made this reduction to zero completely by our strategies in all these systems. And at the end, we only propose 50% of the roof coverage by PVs. So it's not even something crazy like you have to install PVs in all your facade and all your roof coverage. So just to finish, I want to say that if you are interested in seeing more and seeing how like this report can be used for your project and like the value on these simulations, even if you are not pursuing net zero, if you just want to compare it with different scenarios, HVAC systems, building and below values, um, we have this report available for you as a project assist service. So just reach out to us in our page. Ooh, oh, I'm sorry about that. Um, and also you can reach out here at the just scan the QR code for Project Assist, and that will take you to our page and to our services too. So thank you so much for joining me. I would love to see now if we have some questions. So please go to someone. So unfortunately, someone was asking me to go to the last slide. Unfortunately, it's not something that we could do. I don't know if you're interested to see the projects, the roadmap, or what last slide are you talking about? If you can reply, I will see your question right now. Nothing? Okay. Does anybody else has any questions? Okay, I think not. So anyway, thank you so much for joining me today. And please just reach out, scan the QR code. You can reach out in any social media too, LinkedIn, Instagram, anything that you want.